And on to question 11. So I'm just going to zoom out a little bit. Okay, here is a bias spinner. When the spinner is spun once, the probability that it lands on red or on yellow or on green are given in the table. So red, yellow, purple. Okay, so slight mistake in the question. It lands on red. The probability that it lands on red, yellow, or green is given in the table, but it says that's red, yellow, and purple. No major drama though. Work out the probability that it lands on red or yellow. So I need to add those two probabilities together. So that's going to be, I'll show what I'm doing, 0.25 plus 0.2 is equal to 0.45. Right. Okay, I was just wondering where the name came from. Normally we're introduced to them beforehand. So Young is going to spin the spinner 300 times, work out an estimate for the number of times that the spinner will land on purple. So 3-mark question. I think that the mistake in this question is actually that should be green and that should be purple. I'll do it as the question says though, and then I'll do it for green, just because I think that's a more useful skill. Right. So to work out the probability, an estimate for the number of times it will land on purple, I would be doing 300 times by probability of it landing on purple, which we're told here is 0.2. And then we can go to the calculator if we want to, although times by 0.1 would be 30, so it's going to be 60. Right, I've done my math right, which I'm confident of. 60. Right, so I'm looking at 60. I am actually going to do this just as a secondary, because that's not really worth 3 marks. There is a mistake in the question. The mistake is these two names should be switched over. So I'm going to do a separate, I'll do it in green. So the number of times that it would have landed on green, I'll do as a second question. So the probability that it lands on green. So the probability of green, first of all, is going to be equal to 1 minus the other 3 probabilities, which are I'll actually go a little bit further, 0.25 plus 0.2 plus 0.2. So that's going to be 246.5. So 1 minus 0.65 is going to be 0.35. And then, so the probability, so the number of greens that we would expect would be 300 times by 0.35. And that gives us 300 times by 0.35, which would give me 105. So that's the number of times I would expect it to land on green. Just because I think that's the correct question. Right, I will find out. I'll look at the mark scheme. So for question 11, for the first part then, for part A, it is a B1 just for 0.45, so B1. And then for question 2, yes, as I thought, they've got the answer 105, so they've not spotted the mistake there. So I'll do the mark scheme for this. It is, what are they saying? M1 for use of their 0.45 from part A, which isn't actually part A, but we'll go M1 for that. M1 for complete method, so M1 for that, and A1 for that. So that's if we were doing this. And you can kind of understand why I would be struggling to pick out 3 marks for this version. So we will go for, I would guess, identify 0.2. You can have 1 mark. I actually call that a processing mark. I know these mark schemes don't have processing mark, but you've picked out the right M1 and then A1. Okay. I'm just going to make a note of that just because I'll email Pearson after this and just point out any other issues that we spot. I did that for paper ones as well. Okay, for question 12, here is a list of 7 numbers. From the numbers in the list, write down a cube number. So cube number, this is the only cube number. This is 3 cubed. It's 27. Cubed means times by itself 3 times. We can double check. So cubed, 27. We're just trying to spot whether any of the others are. If you're unsure of this, you can literally cube root every number and show that, and just check for yourself that none of them are cube numbers until you get to a cube number. If you're not particularly good at spotting it, that would be an absolutely fine method for that question because we're on a calculator paper. Next, a factor of 80, so a number that has 80 in its times table. And it does say a factor, so I'm going to go for the first one, which is my standard method. So I would go for 5, but interestingly, 5 times by 16, so 16 would be another acceptable answer. I would strongly recommend, though, if you're doing this in an exam, you only put 1 down because it does say A. But I'm going to just put that in brackets to show the other possible answer. Actually, I'm going to just clear up because if somebody was actually looking at this, 5 or 16, and then just write one of them down. As 2 numbers in the list are prime, work out the sum of the 2 prime numbers. So we need to identify the prime numbers. So your method for identifying these is kind of up to you. We've already identified that one can't be a prime number. I've crossed out all of the non-prime numbers. So that just leaves me those 2. So work out the sum of the 2 prime numbers. So 5 plus 23 is going to be 28. And that's it for that page. So if we go to the mark scheme then. So which question was it? Again, question 12. So 27B1. Did to say 5 or 16, but either or both indicated. So I've indicated both. So there we go. And then we've got M1 before. Let me just see, at least 1 prime identified. So if you've only identified one of the prime numbers, you get method mark. But we're going M1, A1. Right, question 13. Here are 5 cards. The mean of the 5 cards is 12. Work out the value of X. So I'm going to help myself out a little bit here. I'm going to add these numbers up first. I'm going to show what these 4 numbers add up to using my calculator. So 15 plus 7 plus minus 2 plus 23 gives me a total of 43. So X plus 43 must be equal to 12 times by 5. So X plus 43 must be equal to 60. So minus 43 from both sides, X must be equal to 17. Right, and that's it for this page. So if we go to the mark scheme for question 13 now, a method to find the total of the 5 numbers by setting up an equation in X43 comes from. So, M1 for complete method. Just looking at the mark scheme, they've virtually written the same thing twice. When we get an equation with this 60, or for a complete calculation to find the value of x. Okay, so we're going to go M1, second M1 there, and then an A1 for the 17. Right, question 14. Salma asked some people what type of exercise they like the best, from walking or running or swimming or cycling. Salma is going to draw a pie chart for her results. The incomplete table gives some information about her results. So walking, we've got 18, and that has an angle of 90 degrees. Running is 150. Swimming, blank, blank. Cycling, we have 15 people. 18 people answered walking, so it does say that there. How many people answered running? So we can kind of do this one of two ways. I'm going to do, if I can do this as a ratio table. So if divided by 90 would be equal to 5/3. So times by 5/3 there. So if I times by 5/3 there, that would give me the answer. So I'm looking at 30. That's a fairly quick way of doing it. There is a longer way. I'll do that as well, just to show you. So secondly, I could have said, well, if 18 people represent 90 degrees, then each person is going to be worth 90 divided by 18. So each person is going to be worth 90 divided by 18 is going to be worth 5 degrees. So 150 people. So each person is worth 5 degrees. So 150 degrees divided by 5 would be representing, so wrong way around. 150 divided by 5 would give us 30 as well. Okay, so we get 30 either way. Your method is up to you. 15 people answered cycling, so we've got that. How many people answered swimming? Okay, so are we told the total anywhere here? Okay, so there are two ways that we could do this. I'm going to stick with this way. So if each person is worth 5 degrees, then the total number of people asked would be 360 divided by 5. There are a total of 72 people that were asked. I was just taking a second to just see whether it stated that in the question anyway. So if I do 72 minus the numbers that we know of, so 18 plus 30 plus 15 is going to give us 72 minus open bracket 18 plus 30 plus 15. So we've got 9 people. So 9 people. And the other method that you could have done is you could have worked out the angle that was associated with cycling. You could have said that the total angles in a pie chart need to add up to 360 and found the missing angle. And then from there, having found out the angle for swimming, worked out the number of people. But I think that's a slightly longer method, so I think that's the better of the two. Right, that's the only question on that page, so I'll go to the mark scheme. So question 1, M1 for complete method to find the number of people for running. So I'll do it in blue because I've done 2 different methods. So I could award the M1 here. M1 and then A1 for the 30, and then if I did it here, then in effect can't really award the M1 here. I'd need to award the M1 here, M1 and then A1. Reason I can't award it here is it says the complete method, and that's only a partial method. That's a method to find the number of people. So there we have a complete method. There we have a partial method. Right, for part B, M1 for working out the angle for swimming, or the total number of people. Check the table for answers. Follow through. There 5. So they are saying M1 for my method, M1 for the 17. Sorry, for the 72. M1 for complete method to work out the number of people for swimming. And so we've got an M1 there, and then an A1 for the 9. Right then, question 15. It takes a machine 8 seconds to produce a bolt. Each day the machine starts producing bolts at 9:30. The machine produces bolts continuously every 8 seconds until it stops at 16:10 on the same day. Work out how many bolts the machine will produce each day. Okay, right. So in effect, we need to work out the time difference between, to start with, we need to work out we've got a few options here, but the first thing I want to do is to work out the time difference, the time that the machine's running. So if I say, and I'll do 2 quick methods for this. So if I was going, I would say I find working out time differences easiest by chunking, particularly if I've not got a calculator. So that would be a difference of 30 minutes. Then I'd chunk to the closest hour. So that would be 6 hours. And then we've got another 10 minutes. So we've got a total of 6 hours and 40 minutes. We could do this on a calculator though. We could use our time function on our calculator, and we could say 16 hours and 10 minutes. And from that, I want to subtract 9 hours and 30 minutes. And that gives us 6 hours and 40 minutes. So that's how long the machine is running for. So I'm going to convert that to being a decimal hour. So in effect, it's going to be working for 6 2/3 of an hour. Hours. And then I'm going to work out the number of bolts that the machine would produce in an hour. So if it produces, so the number of seconds in an hour are, well, there are 60 seconds in a minute, and there are 60 minutes in an hour. So the number of seconds in an hour is going to be 60 times 60, and I want to divide that by 8. So 60 times by 60 divided by 8 gives us 450. So it would produce 450 bolts in 1 hour. Bolts per hour. The total number that it will produce in the day is going to be 450 times by 6 2/3. So 450 times by, and I want to enter a mixed fraction. Shift, that's my mixed fraction, 6 2/3. So it's going to produce 3,000 bolts. And there are going to be other ways you could have done this. You could have worked out the number of seconds in 6 hours, 6 2/3 of an hour, or 6 hours and 40 minutes, and then divided that total by 8. I just think that that's probably the most efficient, but not the only way by any means. Right, where did the marks come from then? there is a B1 for working out the length of time in either hours and minutes, hours as an improper, hours as a mixed fraction, hours as an improper fraction, or 400 minutes. So we will go B1 there. We then get a method mark for converting their time difference into seconds, or finding the number of bolts produced in 1 minute, or finding the number of bolts produced in 1 hour. So we pick up our M1 there, and then it is M1 for complete method to find out how many bolts are produced. So we've got M1 there, and then a 1 for our 3000. Right, question 16 then. So Molly uses this number machine to work out the amount of tax she should pay on the money she earns. Number of hours worked multiplied by 12, add 50, multiplied by 0.2, amount of tax to be paid in pounds. When Molly works N hours, the amount of tax she pays is T. Find a formula for T in terms of N. So the tax is going to be equal to, I'm just kind of, so my processes are going to be multiply by 12, add 50, and then multiply by 0.2. So I can kind of write this in order. However, this multiply by 2 has to be a multiply of this whole thing by 2. So it needs to be written first, really. So 0.2 times by number of hours, which is going to be 12 times n, or 12n, plus 50. So there we go. That's all I'm looking for. That seems quite a lot for not. That seems quite quick for 3 marks. Another way you could look at this, trying to think of a method that might be slightly more deserving of 3 marks, because that seems quite straightforward. So let's just pretend that I put T in. So no, sorry, we put N in, and then we would get T out in effect. So that step there would be 12n. That step there, but then would be 12n plus 50. My n's missed. 12n plus 50. Multiply by 0.2, so I need to multiply by 0.2, 12n plus 50, and out we get t. So t is equal to 0.2, 12n plus 50. Okay, and that's the only question on that page. So the mark scheme tells us T1 for, oh no, it just says, there we go. So we can actually pick up 3 marks just for the solution. And then it's going to be a B2 for B2 if you have any one part missing. So any one part missing or incorrect. And then a B1 if there are 2 mistakes. Pretty much. Right, question 17. Jane brought a new car for £18,000. The car depreciated by a value of 15% each year. Work out the value of the car at the end of the 4 years. Give your answer correct to the nearest pound. So if a car depreciates by 15%, it means that it's going to be 85% of its original value, which as a multiplier would be 0.85. So for this, I'm looking at 18,000 multiplied by the multiplier, 0.85, to the power of the number of years, so to the power 4. So I type it in just like that. 18,000 times by 0.85 to the power 4. And that gives me a value of 9,396.1125. So to the nearest pound, then that's going to be 9,396. 9,396. Right, and again, that's it for that page. So the mark scheme for this then says, where are we? M1 for finding 15% or 0.85 of. Right, Right, for mine, it is saying that for this line here, I can pick up M2. If you've not done that, but you've either found out 15% of the original amount or 85% of the original amount, then you can pick up a method mark. And then if you've worked that through fully, you pick up the second method mark. If you use the compound interest formula, then you just 2 method marks and then an A1 for the answer. Okay, question 18. Write 1,200 as a product of its prime factors. Show you're working clearly. So for this, so I tend to always do my factor trees in the same way. I always pick off the smallest prime factor, which is in most cases, well, in a lot of cases, 2. So that's going to be 2 times by 600, which is going to be 2 times by 300, which is going to be 2 times 150, which is going to be 2 times 75. 2 is not a factor of that anymore, so the next smallest one is 3. 3 times 25, which is 5 times 5. So my factor tree looks a little bit lopsided because it's right side heavy, but for writing it as a product of its prime factors, the fact that I took out the smallest ones first of all means they're in order. So it's going to be 2 times 2 times 2 times 2, so 2 to the power 4, times by 3, times by 5 squared. And then just double check, put them back in, 2 to the power 4, times by 3, times by 5 squared. And there we go. So that's that question, and that's 3 marks and the only one on the page. So what does the mark scheme say for question 18? It says M1 for at least 2 correct stages of the prime factorization. So in effect, that's stage 1, that's stage 2. So I would pick up that M1 there. M1 for finding the correct prime factors condone inclusion of 1 may be seen as a fully correct factor tree or ladder. So I pick up that second method mark for the complete factor tree, and then an A1 mark for, and I can't really see it in the mark scheme. Zoom in because it's shrunk down lots. 2 to the power 4 times 3 times 5 squared. Yeah. So I'll put it up on the in front of you. You can see why I'm so much sharper on this screen than it was on my other one. Yeah. Okay. So we get the A1 mark there. Right. Question 19 then. So the language department in the college has 180 students. Each student studies exactly one of French, German, Italian, or Spanish. 15 students study French, 45% of the students study German. Express the fraction of students studying Italian or Spanish as a percentage of those studying French or German. Okay, so in effect, so I'm going to put all 4 in to start with. We've got French, German, Italian, and Spanish. So I'm kind of going to do this in a couple of stages. So I'm going to go for numbers of each, and I'm going to go for percentage of each, and I'm not going to fill all of these in, and then I'm going to do combined numbers. Because for my combine, I want those 2. I want French and German, and Italian and Spanish. Right, so starting off, we're told that we've got 180 people in the college. We're told that 15 of them study French. And we're told that 45% of the students study German. Okay, so I'm going to go for, I want combined numbers. So 45% of 180 is going to be my first step. So 180 times by 0.45 gives me 81 students studied German. So that's just 45% of 180. And actually, I think that's the only step I need to work out, really. I'll show that that's what I've worked out. I'll even put it here, 81, not 81, 180 times by 0.45 is equal to 81. Right. So from there, I can actually go straight to this point, and I can say that then the total number of students that studied French or German is going to be 15 plus 81. I've got 96 students that study French or German, which means that 180 minus 96. So we've got a total of 84 that studied Italian or Spanish. So as a percentage, I'm looking for Italian or Spanish as a percentage of those studying French or German. So I'm going to go 84 divided by 96 times by 100. And that's going to give me fraction 84 over the answer that I just worked out times by 100 gives me 87.5%. So 87.5. And that's the only one on the page. So the mark scheme, what does it say? Let me zoom that out a little bit. Zoomed it in last time. So M1 for method to find the number of students studying German. So we are going M1 for that. M1 for method to find the number of students studying Italian/Spanish or French/German. So I'll go for the first one that they've suggested. I'll go M1 there. M1 for complete method to find the fraction or decimal or percentage of Italian, Spanish to French/German. So we've got an M1 there. And then finally an A1 for 87.5. Okay, there we go. And question 20. Kim spends N pounds. Of this, she spends 40% on food, a quarter on clothes, and the rest on petrol. Kim spends P pounds in petrol. Work out the ratio P to N. In the form A to B, where A and B are integers in their simplest form. Okay, so in effect, we've got three categories. We've got food, we've got clothes, and we've got petrol. So currently, it starts off saying that that's 40%. It then says that that is a quarter, and we have not got petrol as a percentage first of all. So the way that I'm going to do this is I'm going to say that what a quarter as a percentage is going to be 25%, which means that that's 65%. So that's got to be 35%. And then the total N is the total. That would be 100%. So if I'm trying to do P to N, it's going to start out as 35 to 100. And then the highest, well, I'm not fully sure where it's the highest. Fives go into both numbers. So 5 would go 7 times into 35. And it would go 20 times into that. So, and I can't cancel it down any further. So I'm going 7 to 20. Right, and we'll go to the mark scheme again. So for question 20, where are we? M1 for correct conversion of either converting that or for converting that. So we pick up our first M1 for that there. M1 for complete method to find the proportion of money spent on petrol. So we're going M1 there. An M1 for an equivalent ratio, and then an A1 for the simplified ratio. Okay, there we go. Right, and that was question 20. So I will restart the video for the last part of the exam.